In my first order magnitude cube of 6 tetrahedral blocks, I have the choice. For example, let me take this color away, because it's going to be... So here I have 6 double corners, left and right. So everybody can see it, 6 double corners, left and right, and I'm gonna make a cube. Now if I would make them into a MITES, I cannot build a cube. So the MITE is a module which is twice as bigger than double corner, and I cannot build a cube. It's impossible from 3. However, if I make a square base pyramid like that, this is a half irregular octahedron, and I do the other one, and I do the other one, I can make a cube. So we see that this is the lowest common denominator. Of course, a synergy is again far short of this kind of demonstration. But what I want to show in here and compare to synergetic, that indeed this particular cube is 100% left and right. Just like in synergetic, where the one frequency cube or a first order magnitude cube contains 72 blocks, as we showed, 24 in here and then 48 in, no, 24, yeah, and 48 of these modules in a larger scale, octants. So I hope everybody can see what is the meaning of doing more with less. Obviously, synergetics can do more with less. Synergetics does the reverse, doing less with more. Now let's build a cube by all neutral blocks. These are neutral blocks. These have no left and right orientation. Let me build a cube. These are the 3 solid kites, fuse them like that, and we have a regular tetrahedron and an octant. Now this was not known to Synergio guys, any of the Synergio guys, and it was not known to Fuller probably, because otherwise he would start his concentric hierarchy with irregular tetrahedrons and not with these monsters. But anyway, so we see we have a regular tetrahedron and an octant simultaneously. Why this is very clever? Because the regular tetrahedron doesn't fuses with anything else other than these blocks. So regular tetrahedron, these blocks build the octahedron, regular tetrahedron fuses with octahedron. That's his 60-degree vector matrix. So we see that we have 3 blocks in here, and then we have additional 3 blocks in here, because the cube is always 6 blocks, cannot be any less. And here we have our cube, completely made of 100% of neutral blocks. Now let's build a cube by 4 double corners. These are just one of it. There are even more combinations. I just don't want to go in it. But let's say we have 4 double corners. and we're gonna use one octant and one solid kite. Now in this construction we see that 2/3 of the blocks in here are indeed left and right, and only 1/3 is neutral. And we of course again can build a cube like that. Then we gonna put this like that. Then we do this, this, and this. There is a cube, just like the rest of the cube. Now this is 2/3 of left and right. But the most diverse combination, and this is the most important combination of them all, where we're gonna have a alternation, we're just gonna pair shapes. Alright. And this is the most diverse combination. We're gonna have 2 left and right, we're gonna have 2 octants, and we're gonna have 2 solid kites. Now this combination is the most diverse because it can build a whole hierarchy of solids, and it can build hexahedrons, dodecahedrons, you just name it. I mean, it goes, this is the most. Now I can fill space with just left and right double corners, of course, or I can do it where the 2/3 of the blocks gonna be left and right and only 1/3 gonna be neutral. But they're gonna be limited because with these, if they come in pair, 1, 2, 3, if they come in pairs like that, I can build just about anything. There is actually no structure I could not build with there is no structure which I could build with these, only left and right, and I could not build with the combination of these. The combination of these is the most diverse. Of course, again, I have to highlight that Synergetic had never even had a clue about this. Since I've been communicating with them for years on and off, I know that had no clue about this. So this is the most diverse combination. The second order magnitude cube, or 2F cube, in my scheme, from 48 blocks are neutral. This is 80% of neutrality, and only this ratio of neutrality in a 2 frequency cubes is the most diverse. In Synergetics, the cube contains 72 blocks, all of which are left and right, 100%. There is no choice, only one way to build a cube from A and B modules. I'm not sure what is the advantage, and I'm sure nobody else does, since no A or B modules on their own are capable of any structuring. There is absolutely no advantage to be 100% left and right as Kirby states. And the main difference between Synergetics and my dissection is that I have the choice of diversity with less blocks. In Synergetics, it is reversed. It does less with more blocks. So please, Synergy you guys, remember that. I have no complementary blocks like the regular tetrahedron and the regular octahedra. All these are built by my 3 modules, which I just demonstrated, derived from my cube. I hope this fact of simplicity is clearly visible. The third statement from Kirby's block. Because the regular tetrahedron does not fill space, but Mr. Fuller comes up with the minimal tetrahedron that is neither left or right, though we can create that if we like. Well, this is what he's talking about. Here is a MITE. I am showing a MITE. Synergetics MITE. This is from a different set. And it's made up of 2 double corners. I want everybody to see. So these are double corners, and this is a trirectangular tetrahedron, also known as MITE. And we see that it's composed of left and right A modules and then a B module. And this is how it looks on the bottom.